Bismillahirrahmanirrahim. My today's lecture is about the solution of partial differential equations. So, before starting the solution of partial differential equation, I would like to start from the introduction. So, what is a partial differential equation? An equation involving or contain one or more partial derivative is known as partial differential equation, and there are two types of partial differential equations are very common, which are known as homogeneous partial differential equation and non-homogeneous partial differential equation. How you can recognize partial differential equation is homogeneous or non-homogeneous? If we have a function here, you can see that in the example we have a function with partial derivative of function u with respect to x, and with a partial derivative of function u with respect to y. So we have two partial derivative of function u with respect to two different variables. These are known as partial differential equation, and right hand side is the equation of partial differential equation is 0. So this types of differential equation are known as homogeneous partial differential equation. Similarly, if we have similar partial differential equation with f of xy at right hand side, such kind of differential equations are generally known as non-homogeneous partial differential equations. How to form the various kind of partial differential equation? For forming the partial differential equation, we must have a function which consists of the multiple variable, or there are also several techniques which are by which we can form a partial differential equation. So here I would like to discuss regarding formation. So look at this, how to perform or how to form a partial differential equation. So here a partial differential equation can be formed by using two methods. These two methods are known as elimination of arbitrary constant and elimination of arbitrary functions. So these two methods, which are very famous to form the partial differential equation, or these are typical method to form a partial differential equation. So we will discuss one by one by solving some examples. So example number one is here. In example number one, we would like to obtain a partial differential equation by using elimination of arbitrary constant. For the following function, we have a function z, that is ax square plus by square plus ab. So here we have a function z consists of two independent variable, which are x and y, and where a b are arbitrary constants. So for formation of partial differential equation of function z, because we have two arbitrary constant, we must be remember that when you are going to form the partial differential equation, it is similar as formation of ordinary differential equation. For formation of ordinary differential equation, we differentiate the function with respect to the time of the given arbitrary constant. So same method we will apply here for the in the technique of elimination of arbitrary constant. If we have one arbitrary constant, so for formation of partial differential equation, we will differentiate one time. We have two arbitrary constant, we will differentiate two times. So here in this equation, z is equal to ax square plus ax square is equal to z is equal to ax square plus by square plus ab. Here we have two arbitrary constant a and b, so therefore we will call it equation number one and differentiate this equation number one two times. One time first with respect to x partially, and second with respect to y partially. So we'll differentiate equation number one partially with respect to x and y. When you will differentiate equation number one partially, so the derivative of equation number one with respect to x, that would be double z upon double x is equal to a derivative of x square is 2x plus rest of all the terms we are keeping constant because we are differentiating partially. When we differentiate partially an equation with respect to a specific variable, always remember that the other variable always keep as a constant. So here y and ab, those which are separate to the x terms will be clearly taken as a constant term, so the derivative of constant term would be 0. So the derivative of by square plus ab all are 0, therefore second term and third term will be 0. So similarly you will differentiate function with respect to y, that would be double z upon double y is equal to, now x would be the constant here, so the derivative of first term ax square would be 0, or and we will differentiate only uh, y squared term. So b is the coefficient and the derivative of y square, that would be 2y plus uh, derivative of ab would be 0 here. So that from this equation, first equation double z upon double x, we will equate p, and you know that one thing which I would like to also mention you, double z upon double x can also be written as a small p, and double z upon double y can be written as small q. Here p is double z upon double x and q is double z upon double y. So this equation can be written as p is equal to 2ax and q is equal to 2ay. We will call it equation number 2 and equation number 3. So this is the very first step in toward the formation of partial differential equation. Now we will eliminate the arbitrary constant which are a and b from equation number 2, 3 and 1. So what we have to do, we will eliminate the values of a and b from equation number 1 and 2 and substitute in equation number 1. So look at this here. Equation number 1 becomes z is equal to p upon 2x into x square. This is the value of a from equation number 2, p upon 2x into x square plus q upon 2y. This is the value of b into y square plus a into b, that is value of a, value of b. Now we will simplify a little. Z is equal to px square upon 2 plus qy square upon 2 plus bq upon 4xy. And by cross multiplication, this equation may be written as 4xyz is equal to 2x square yp plus 2x y square q plus pq. So which is the required partial differential equation. And keep in mind here why we are calling this equation is a partial differential equation, because here we have small p and q, and small p represent the partial derivative of function z with respect to x, and q represent the partial derivative of function z with respect to y. Now we have another example, example number 2. We are going to form the partial differential equation of this function. We have z is equal to x plus a whole square multiply y plus b whole square. Now we have two bracket in term of multiplication with whole square, so we will call this function equation number 1. And here we have two arbitrary constants a and b, so what we have to do, we will differentiate this equation number 1 one time with respect to x partially and second time with respect to y partially. So we will differentiate equation number 1 with respect to x, that would be double z upon double x is equal to 2. What is this 2? 2, we will differentiate only this one. So here, because we have x here, so when you will differentiate, this will treat as a power function, and according to the power rule, we will shift the power into the base and 1 will be reduced from the power, so that the derivative of this one becomes 2x plus a. And this one is a constant term, so it is in the coefficient of this term, so that this will remain same. So this is equation number 2. Similarly, when we will differentiate with respect to y, so that left hand side becomes double z upon double y and right hand side would be 2y plus v, that is the derivative of second term with respect to y containing the y. That is why we are differentiating this term. This is the power function, so according to the power rule we can differentiate it. Power will be shifted into the base and 1 will be reduced from the power, so that it can be written as 2 multiply y plus b. And this this first term consists of a entirely, because due to the product will be the treating as a coefficient, so it will remain as it is. Now we have equation number 2 and equation number 3. From equation number 2 and 3, how we will eliminate the arbitrary constant a and b from here. And as you know that double z upon double x would be p small p, and double z upon y would be small q. So here, by dividing equation number 2 by equation number 3, we will obtain what? Look at this. Why we are dividing? Because due to the division, this similar factor will be cancelled out. That is why, because these brackets are same, so that is why we are dividing these two equations. So left hand side always will be divided by the left hand side, and right hand side will be divided by the right hand side. So P upon Q is equal to 2x plus a into y plus b whole square divided by 2y plus b into x plus a whole square. 2 will be cancelled out, x plus a will be cancelled out, y plus b will be cancelled out. So since linear power of y plus b and linear power of x plus a, these two terms will be the remaining terms in the equation. So the equation becomes P upon Q is equal to y plus b upon x plus a. We will call it equation number 4. From this equation, what we have to do? From this equation, by the cross multiplication, we can shift x plus a from right to left hand side, and P upon Q at the right hand side. So by the cross multiplication, we can shift these two terms, and x plus a will be transformed here. That would be at left hand side, x plus a is equal to, and this P upon Q will be reciprocal Q upon P into the multiplication of y plus b. So here we have got the value of x plus a, and we will substitute this value of x plus a in equation number 3. Now equation number 3 becomes, what is equation number 3? Equation number 3 implies that q is equal to 2y plus b q upon p y plus b whole square. What was the equation number 3? Equation number 3, I will show you that this was our equation number 3, that is q is equal to 2y plus b x plus a whole square. So here we are substituting the value of x plus a here. So after substitution of the values of x plus a, equation number 3 becomes q is equal to 2 times y plus b q upon p y plus b whole square. Now further, q is equal to 2 times y plus b into q square upon p square y plus b whole square, or y plus b into y plus b would be the y plus b whole cube. Now shifting the y plus b from left hand side to right hand side, and q from left hand side to right hand side. By the cross multiplication, this equation we can write it as y plus b whole cube is equal to p square upon 2q, and because we would like to get the value of y plus b, because we have y plus b whole cube, so we would like to cancel this cube, so that we must be applied cube root on both sides. So taking cube root on both sides, so left hand side can be written as cube root of y plus b whole cube is equal to cube root of p square upon 2q. So this cube root will be cancelled out to the cube root, but we will obtain the value of y plus b at right hand side. P square upon 2q becomes p square upon 2q whole power 1 upon 3. That would be equation number 5. Now we have obtained the values of y plus a and y plus b. These two values we will substitute in equation number 1, or in equation number, or also we can substitute this value of y plus b in equation number 4. So equation number 4 becomes p upon q is equal to p square upon 2q whole cube power 1 upon 3 divided by x plus a. So implies that from here x plus a is equal to, by cross multiplication, p square upon 2q whole power 1 upon 3 divided by p upon q. And here little simplification is there, how this power will be implied, and how we get this directly. So directly I can write it equation number 1 as, this is the value of x plus a, and that was the value of y plus b. Now substituting the value of x plus a and y plus b in term of p and q in equation number 1. Now equation number 1 implies that is z is equal to, equation number 1, that would be, equation number 1 becomes z is equal to, this is the value of entire value of x plus a, this is the entire value of y plus b, and whole square, both the terms containing the whole square, so that p square upon 2q whole power 1 upon 3 divided by p upon q whole square, p square upon 2q whole power 1 upon 3 whole square. Power, both the power will be multiplied so that the power of first factor becomes 2 upon 3 and second term will be also 2 upon 3. Further simplification by breaking the power. So this term can be written as p power 2 to the 4 upon 3 and also in the denominator where we have p square, that would be basis same power combined, or we can write them separately. So this is only the game of simplification here. I write here 4 upon 3 plus 4 upon 3, that is 8 upon 3. By the simplification power, these all power will be simplified because similar uh, alphabets are multiplying, so their power will be combined or simplified together. After the simplification, q square upon 2p whole power 2 upon 3, p square upon 2q power whole power 2 upon 3. Now we have q square upon 2p whole power 2 upon 3. So how? By taking cube root on both sides. Taking cube on both sides. When we will apply cube on both sides, here what that would be z cube. At here cube will be cancelled out from these two terms. Only square will be the remaining power here on these two brackets. So when we have power on power, power will be multiplied simply. Z cube is equal to q raised to the power 4, p raised to the power 4, and in the denominator that would be 4p square 4q square. Denominator will multiply and similar power will be cancelled out, so that q4 q square, that would be q square, p4 p square, that would be p square. So z cube becomes p square upon p square q square upon 16. So the required partial differential equation would be 16 z cube minus p square q square is equal to 0, which is the required partial differential equation. Now example number 3, here we have, in example number 3 we have formed the partial differential equation of by elimination of arbitrary function. Here in this example we would like to form the partial differential equation by eliminating the arbitrary function, and here we have two different we have function, that is z is equal to f(x) square minus y square. So this function is known as arbitrary function. We would like to form the partial differential equation by eliminating this arbitrary function f. So here how many dependent variable here, x and y, which are the independent variable, and z is the dependent variable. So we would like to differentiate this equation number 1 with respect to x and with respect to y partially. So the partial derivative of equation number 1 becomes double z upon double x is equal to derivative of f, that would be f prime, right? We have, suppose, do not see this term, only look at this f. If think about this, only when we have only f, what will be the derivative of f? Derivative of f will be the f prime. So here look at this, derivative of f, that would be the f prime. Now derivative of angle, so angle is what here? X square plus x square minus y square, and we are differentiating partially, so y would be the constant here, so we will differentiate only 2x, and derivative of 2x would be 2x. So this is equation number 2. Similarly, when differentiate with respect to y, that would be double z upon double y, and derivative of function f, that would be y f prime, and derivative of minus y square, x square minus y square, x square will be 0, and derivative of minus y square, that will be with respect to y minus 2y. So we have equation 2 and 3 here, and you know that here what are the values of double z upon double x and double z upon double y. We know that double z upon double y would be p, and double z upon double y, double z upon double x will be p, double z upon double y will be q. So for instance, we will substitute p and q, and together with we will divide equation number 2 by equation number 3. So at the left hand side we will get p upon q, that is equal to right hand side, that is f prime into 2x divide f prime into 2y. This f prime will be cancelled out, so and 2 will be cancelled out, only we will get minus x upon y. So p upon q, that will be equal to minus x upon y by cross multiplication. So after cancellation we will get P upon Q is equal to minus X upon Y. After cross multiplication, Px is equal to minus Qy. So shift here. So Qx plus Py is equal to 0. This is our required partial differential equation after elimination of arbitrary function. So you must keep in mind. So thank you for your uh, watching my lecture. I would like to request you, please, if you like my effort, like and subscribe my channel. I would be really thankful to you. Assalamu alaikum.